Hey, previously we tested and created transaction objects. They have unique IDs, and a transaction output map field details the amount sent to the recipient and how much balance the sender will have remaining after the transaction. There's one more crucial element to add though, and that is the transaction input. The input portion of the transaction will make the transaction official. By including a signature in the input, the sender wallet officially validates the transaction. Let's start by creating this input section by adding a new input portion to the tests. So after the output map portion, let's add a new section to capture some tests for the input section of the transaction object. So similar to the ID check, as well as the first output map check, we're going to check whether or not it has an input. And then in the callback function for the test, we're going to expect the transaction to have that property using the toHaveProperty method of jest. So toHaveProperty, and the property name is input. Cool. Now let's add some tests for the various properties that will make up the transaction input. First up, these transactions should record when they were created. Therefore, the transaction inputs need to have a timestamp property. We can construct a similar test, so we can say it has a timestamp in the input. So it has a timestamp in the input. And then again, we can use the toHaveProperty method, except this time we're going to look directly at the transaction input object itself. And then this should have the property of timestamp. Cool. Next, the transaction input is also going to contain the sender wallet's original balance. Now, in terms of the input object, this will be called the input amount. So let's say that it sets the amount, so that's going to have an amount field, to the sender wallet balance. So that way we know for sure that the amount matches the balance that is contained in the sender wallet. For this, we can run an equality check. The actual value is the transaction.input amount, and the expected value is the sender wallet.balance. Overall, we're going to expect the transaction input.amount to equal the sender wallet.balance. Next, the input object should contain the sender wallet's public key. That way, other users can verify that the transaction is valid. So recall that the public key is one of the fields given to the verify signature method. Therefore, it should be used to verify the transaction itself. The test will say it sets the address, which is a keyword noted by backticks, to the sender wallet public key. And our test for this is going to be very similar to the one right above. We're going to look directly at the actual value of the transaction input.address. And this should be equal to the expected sender wallet.public key. Cool. Finally, we'll expect the sender wallet to sign the input. The input will have a signature field. So let's make sure that the signature can be verified. Now, the public key is already the sender wallet's public key, which is the transaction.input.address. The data for this transaction is the entire output map. So let's acknowledge this when we have a test that says it signs the input. We're going to ask that we verify the signature. So let's call verify signature. This takes in a public key object, which again is the sender wallet.public key. The data of that signature is the transaction.output map. So have that as the data field. And the signature itself is going to be contained in the transaction input. So overall, that is transaction.input.signature. And the return value of this is that we're going to expect this to be true. So overall, we want this verify signature to return true because indeed the wallet should have signed the input. And make sure you remove the semicolon after verify signature if you had it. So since again, we're using the sender wallet public key, as well as a transaction output map data, and the contained transaction input.signature, this should return true. Okay, The last thing that we need to do is that we need to import, or rather require, this verify signature method. So at the top of the file, let's make a reference to the verify signature method within an object, which is the result of the util directory / index.js file located one directory back. All right, once you have that, as well as a group of tests for the input, go ahead and run the overall testing file. Now we got a little sneak peek earlier of some tests passing, but overall, we should see a bunch of new tests failing. So that's a lot of red to fix. And at the very top, the first thing that we have to fix is that, well, there's no input property on the overall transaction just yet. So let's fix that first. In the transaction.js file, let's set an input. And the way that we're going to create this input is through a similar helper as our create output map helper, except this time it's going to be called create input. Okay. And then create input, what it needs to do is it needs to return an object as the input field. And as we save that, all right, that passes the first test. Now for the other tests, which is going to require completing this create input method. This create input method will need two fields to create the input. One is the sender wallet and the other is the output map. So first we have the sender wallet, and the reason we need the sender wallet is so that we can generate a signature. And the other field is the output map, which is the data that we're signing as part of this transaction. Nice. And let's make sure the input has these fields in its first call in the constructor. So we're going to pass in the sender wallet that is coming into the constructor as well. And the output map is the output map that we generated, which is at this.output map. So overall, that is the input. It's an object with the sender wallet, and then the output map is this.output map. Very cool. Now we can cover that first test that is still failing, which is that the input doesn't have a timestamp. So let's return a timestamp first of all within the object, which is going to be set to date.now. With that save, we see that we need the amount set to the sender wallet balance. So that is going to be the next part. Let's have an amount field, and this is going to be set to sender wallet.balance. With that save, we should see a different test now. And the address needs to be the sender wallet public key. So let's specify that as well. The address should be the sender wallet.public key. And with that, there should be only one remaining test that is still failing, and that is that we need to sign the input. So let's add that next. We're going to have a signature field, and the signature is going to be the result of calling sender wallet.sign and passing in the output map. All right, very cool. So with that, we've covered the last test. All right, nice. And this completes the input object for the transaction. Really cool. Now transactions are official and signed by the sender wallet. Naturally, the next piece of the project is going to be to add the method that validates these transactions next, since they're now official. Even though these transactions have signatures, we still need some methods to make sure those signatures are real and haven't been faked. So let's get to it.